Hi learners, welcome to the another course. I am Priyanka Gupta, working as assistant professor in Department of Computer Science and Engineering, Data Science at Institute of Aeronautical Engineering, Hyderabad. So our today's topic is various mining methods. So I am going to cover these of the topics: mining frequent item sets using the vertical data format, mining closed and maximum patterns, pattern evaluation methods. Strong rules are not necessarily interesting. We'll also check that. And after that, correlation analysis using some of the methods. Let's get started. Mining frequent items using the vertical data format. So both in the earlier course we have gone through with the a priori and FP growth methods. So both the methods mine frequent patterns from a set of transactions in TID, transaction ID item set format. So TID item set, where TID is a transaction ID and the item set is the set of items bought in a transaction TID. So we need to work with the transaction ID and as well as with the item sets. So this is known as the horizontal data format. This is known as the horizontal data format. So alternatively, data can be presented in item transaction ID set format. The algorithm is for that FP growth mine frequent using a FP tree by pattern fragment growth. The input we will give for that D, a transaction database. A transaction database, the minimum support count threshold we will give, and the output will be for that the complete set of frequent patterns. So the method we are using, the first step is what it will do. It will do the first FP tree. It will construct the FP tree. So first it will scan the transaction database D first, and then it will collect F, the set of frequent items. F is nothing but the set of frequent items. First we need to scan the transaction database, and after that we need to collect the frequent item sets from that. After that we need to count their support count. Support. Then we will sort the set of items, the set of frequent items in the support count, in the descending order. In the descending order. Descending order. So, we will then sort the support count in the descending order that we are calling as L, the list of frequent items. After that, we need to create the root of an FP tree, and then we will label it as a null. Null. So for each transaction trans in D, that will do, it will select and sort the frequent item sets in the trans according to the order of L. Order of L. So let the sorted frequent items in list trans P, it will be the small p and p. The list will be the small p and p, where small p is the first element and p is the remaining list. Then we need to call insert tree. Then we need to call the function insert tree, that is having the list p, p and t, which is performed as follow. If T has a child n such that n item name, P item name, then it will increment n's count by 1. By 1. Else it will create a new node n. Otherwise, it will create a new node n. And let its count be 1. Then till the count will be the 1, then we need to count its parent link will be linked to the T. and its node link will be linked to the nodes with the same item name via the name link node link structure, via as node and link structure. These are the links. So in this structure, it will be generated. It will be linked. So if either if P is a non-empty, then the algorithm call insert tree function. In that P comma N will be recursively, will work as recursive function. Again and again it will insert the links. So second step is the FP tree is mined by calling FP growth function. In that we'll call FP tree comma null, which is implemented as this is the algorithm to implement that FP growth function. So in this we need to write procedure FP growth in bracket tree comma 5, and here are the steps to run for the function. So this is the algorithm for the FP growth. So in that we can say in first step, if tree contains a single path P, then second step will be for each combination that is denoted as beta of the nodes in path P. The third step will be that will generate pattern beta union alpha with support count is equal to minimum support count of the nodes in beta. That will count that will be equal to the minimum support count of the nodes in the beta. Otherwise, for each AI in the header of tree, it will found. Then the next step, it will generate the pattern beta is equal to the AI union alpha with support count that will be equal to the AI dot support count. The next step will be the algorithm of it will construct beta's conditional pattern base and then beta's conditional FP tree beta. And then if tree beta upon 5, then it will check for if beta upon beta is upon 5, then it will call the FP growth as a tree beta comma beta. So in this way the algorithm will work. It will check for the certain rules on each line in each step. So here that is item is T transaction ID set, where item is an item name and transaction TID is the set, that is the set of transaction identifier containing the items, different items. So this type of data format is called as a vertical data set. Earlier we have in the earlier slide we have gone through with the horizontal data format. So this is the vertical data format. So in this subsection we look at how frequent data item sets can also be mined effectively using vertical data format. So which is the essence of the ECLAT, which is equivalence class transformation algorithm. For example, if you are mining frequent item sets using the vertical data format, consider the horizontal data format of the transactional database D. So this is the example. This is the transactional data for the all electronics branch. So this is having the transaction ID and list of item IDs. This is having 10 of the transactions record and their list of items accordingly. So mining can be performed on this dataset by intersecting the transaction ID TDID sets of every pair of frequent single items. single items. On the single item, it will going to intersect the TID sets. The minimum support count is 2. Here, if we will check the minimum support count, that will come as a 2. 2 minimum support. So because every single item is frequent in the table, here we will check. So here we will check in the transaction T100, the items are I1, I2 and I5. In the T200 transaction, we are having I2, I4. In the T300, we are having I2, I3. In the T400, we are having I1, I2, I4. In the T500, we are having I1, I3. In the T500, I2, I3, and so on. So here we can see there are some frequent single items they are repeating. Here we can see the item I2, 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 I2. Here I1. These are repeating frequently. I3, I3, I4. I4 is not there. I4 is there. That is also the frequent item. Rather than that, I5 is not repeating. No, this is also repeating. We can check the first transaction T100, that is also repeating. So we have checked all the single items, transaction items that are repeating one by one. So there are 10 transactions performed in the total. So intersections performed on total, which lead to the 8 non-empty 2 item sets in the table 2. So we will calculate the minimum support in the table 2. So this is the table 2, in which we can see the vertical data format for the transaction dataset T. Here we have taken the item set 1, I1, I2, I4 and I5. Here the transactions we will check for each of the items. So in table 3, we are having the 2 item sets in the vertical data. We need to collect the 2 item set from the 1 item set. Then what we will get? We will check for either I1 and I2 is if there are combination of I1 and I2, so how many times the transaction is going on, so, and the transaction will appear. So we will check the I1 for the I1, I2, the transactions T100 that is appearing in transaction T100, T400, T800, T900. So these are the 4 transactions in which the 2 items set I1 and I2 is repeating, is appearing frequently. So like this, we had this table with having the 2 item sets that is having none other than I1, I2, I1, I3, I1, I4, I1, I5, I2, I3, I2, I4, I2, I5 and I3, I5. So these are the transactions that is appearing for these 2 item sets. In the table 4, we can see the 3 item sets for the similar type. So for the vertical data type. So in this, we are having the item set I1, I2 and I3. These are 3 together. These are 3 together appearing for the transactions T800 and T900. The item set I2, I1, I2 and I5. These are together appearing in the T100 and T800 transactions. So we can notice that because of the item set I1, I4 and I3, I5 each contains only 1 transaction, they don't belong to the set of frequent 2 item sets. So here we can check either I1, I4, I1 and I4, I3 and I5, I3 and I5. So these are having the only one, that is only the 1 transaction T400 and T800, so that we will not count in these 2 as a 2 item set. So they don't belong to the set of frequent 2 item set because they are not frequently appearing in the transactions, only appearing in the one transaction respectively. So based on the a priori property, a given 3-item set is a candidate 3-item set. That only if everyone is its 2-item set subset is frequent. So the candidate generation process here will generate only 3-item sets. What it is? I1, I2 and I3. I1, I2 and I5. So in the previous slide, we can check. In the previous slide, here we can check. Here I1, I2, I3 is appearing for the frequent transactions T800 and T900, and I1, I2 and I5. These are the 3-item set. This is appearing for T100, T100 and T800. Yes. So coming to our slide. Here, the candidate generation process here will generate only 3-item sets. That is nothing but I1, I2, I3 and I1, I2 and I5. These are the 3-item sets we got from the 3 frequent item set. So by intersecting the TID sets of any 2 corresponding 2-item set of these candidate 3-item set, it derives table 6. So we'll check the table 6.5, where there are only 2 frequent 3-item set that is I1, I2, I3 belongs to 2 and I1, I2, I5 that is belongs to 2. So that also demonstrate the process of frequent item sets. So the process are, what are the process? First, we transform the horizontally formatted data into the vertical format by scanning the data set only once. So the support count of the item set is simply the length of the transaction ID set of the item set. So starting with the k is equal to 1, the frequent k item sets can be used in the to construct the candidate k plus 1 minus item sets. K plus 1 minus item sets. That is based on the a priori property. So the computation is done by intersection of the transaction ID TID sets of frequent k item sets to compute the TID sets of corresponding k plus 1 minus item sets. That is nothing but k plus 1 minus item sets. So this process, every time this process repeats, which with the k incremented by 1 each of the time. So every time it will incremented by plus 1. So until no frequent item sets of candidate item key will be found. So it will be worked till the frequent item set will be there, or we can say the candidate item set will be there. So this will be the incremented by 1 each time, and then when it will not have the frequent item set, it will stop. So this was the algorithm. This was the process to check the computation of intersection of the TID sets of frequent k item sets. So another method is mining closed and max pattern. So we saw how frequent item set mining may generate a huge number of frequent item sets, especially when the minimum support threshold is set low. Or we can say where there exist long patterns in the data sets. So we already saw that closed frequent item sets can subsequently reduce the number of patterns generated in frequent item set mining while preserving the complete information regarding the set of frequent item sets. So in the earlier methods, we have saw these are the challenges that was occurring there. So thus, in practice, it is more desirable to mine the set of closed frequent item sets rather than the set of all frequent item sets in most of the cases. So if in practical we were having the closed frequent item sets, so we will only mine the closed frequent item sets rather than the all frequent item sets. In most of the cases, we will only take the closed frequent item sets. So how can we mine closed frequent item sets? That is a question. So the recommendation technology, the recommendation methodology is to search for closed frequent item sets directly during the mining process. So for this, it requires us to prune the search space as soon as we can identify the case of closed item set during the mining. So we need to find the, while we are going to search for the closed frequent item sets, we need to prune the search space for to identify the cases of closed item sets while we are doing mining, while we are applying these methods to mine any data set. So the pruning strategy include the following steps. So what we need to do when we are going to prune the data set, we need to search for the space. So in the first step, we will go for item merging. So in the data set, if every transaction containing a frequent item set X, we can say that also contains an item set Y, but not any proper superset of Y. Then the XY forms a frequent closed item set. So this is the condition if every transaction containing a frequent item set X that also contains an frequent item set Y, but that is not a proper subset of Y, then the XY will form a frequent closed item set, and there is no need to search for any other item set that will contain either X but not Y. So we will not search for that. So this was the first step while we need to do the pruning process. So we will need to merge the items. So for example, in the table 2 that we have projected earlier, the projected conditional database for prefix item set I5, yes, in this table we have generated from the pruning process. So in this, we have projected conditional database for prefix item set that is nothing but I5 to 2 is I2, I1, I2, I1, I3. So that we found as a conditional database, for which we can see that each of its transaction contains either item set I2 and I1, but no proper superset of I2, I1. So that is not having the proper superset of I2, I1. So that was the condition we need to check first for the item merging. So here we have checked that process and the condition, and after that item set I2, I1 can be merged with the I5 based on this condition. So to form the closed frequent item set. So the closed frequent item set will be the I5, I2, I1 to 2. So this is a closed frequent item set. While we have checked the condition for that first for merging the some of the frequent data sets, and after checking that condition, we are having the I2, I1 that can be merged to I5. So we have get the I5, I2, I1 to 2. And we don't need to mine for closed item set that contains I5 but not I2, I1. That was the condition earlier. In earlier slides we have checked. So that is based on that condition we find that closed frequent item set. Closed frequent item set. So in this table, as we are checking for this condition, that is having the item I5, I4, I3 and I1 at the condition base we got from that for each particular set, for each particular item, we got these the condition pattern based items, and we got the conditional FP tree from that, and frequent items generated as this. So these are the frequent patterns that has been generated from these items according to the pattern base, conditional pattern base. Now we need to go into the another method after the item merging is sub item set pruning. That is sub item set pruning. So if a frequent item set X is a proper subset of an item set already found in frequent closed item set Y and support count X, so support count Y and all of X descendants in the set enumeration tree, so cannot be frequent item set and thus can be pruned. So while this condition will be checked, after that it will true, then the close that is pruned for the frequent closed item set. For example, suppose a transaction database has only two transactions, that is having the items A1, A2, A till A100, and second is A1, A2 till A50. And the minimum support count is for that is minimum support is 2. Min sub is 2. So the projection on the first item A1 derives the frequent item set A1, A2 to A50 that depends on 2. That is 2. The based on the item set merging optimization technique. So because support A2 is equal to support of A1, A2 to till A50 is nothing but 2, and A2 is a proper subset of A1, A2 to A50. So there is no need to examine A2 item set, A2 item and its projected database. Similarly, pruning can be done for the A3 to A50 as well. So as we have done the pruning for A2, accordingly that we will need to do the pruning for A3 to A50 respectively. So thus the mining of closed frequent item sets in this data set terminates after mining A1's projected database. So that will be terminates after that will mine the A1's projected database. After this process, we will do the item skipping. In the depth first mining of closed item set, at each level there will be a prefixed item set X that will be associated with the header table and a projected database. So with that item set X will be associated with header table as well as with the projected database. So this is the condition we need to check. If a local frequent item P has the same support in several header tables in different levels, we can safely prune from the header table at higher levels. So that was the condition we need to check. After that, if we are having a local frequent item that is having the same support for in their header tables at different levels, we can also prune that. Safely. Now the pattern evaluation method comes. The previous transaction database having only two transactions, A1, A2 to A100 and A1, A2 to A50. So where minimum support was 2 because A2 in the A1's projected data, because A2 was there in the A1's projected data that were having the same support as 2. as A2 in the global header table. So there in that example, the A2 we can prune from the header, the global header table. So that will be A2 will be pruned by from the that header table. That header table. So similarly, pruning can be done for the A3 to A50. As I have said, that also can be pruned for the all the items in this list. So there is no need to mine anything more after mining A1's projected data. So this condition will for this example will also do. These are the conditions. These are the methods. So we are coming to the pattern evaluation method. So what are the patterns in the database? If we are having some type of patterns, some of the text data, some of the some type of we can say social media data. So if we are having the pattern, so we will evaluate that patterns from this method. So most association rules we are having most association rule mining algorithm that employ a support confidence framework. So mostly all of the methods we have gone through till date that are having the confidence and support system. So in there we were checking for the confidence and support. So although minimum support and confidence threshold help to weed out, we can say that is excluding the exploration of a good number of uninteresting rules also. So many of the rules generated are still not interesting for the users. So what we have the methods we have gone through, we are getting some of the rules that can be not useful for the that all the association rules cannot be uh, interesting for the users. So unfortunately this is especially true when mining a low support threshold, a mining for long of the patterns. So that will be true. So what we need to do for that, this is the method pattern evaluation method, where uh, this has been a major bottleneck for successful application of association rule mining. So strongly we are using the pattern evaluation method for that. So strong rules are not necessarily interesting. So we will check why the strong rules will is not interesting for all for us. So whether or not a rule is interesting can be accessed either subjectively or objectively. So we need to assess the rule. It can be subjective, or we can check it as a objectively. So unfortunately, ultimately, only the user can judge if a given rule is interesting or not. It depends on the user. For the end user, if he is not getting the rule as interesting, so and only his judgment, her judgment is matters, being objective may differ from one user to another. So that is a human tendency. If someone's like that rule, other person will not like that same rule. So that is the human tendency. So however, objective interestingness measures based on the statistics behind the data. That is based on the statistics that we have gone through with the earlier course. So that the statistics that is calculating behind the data, so that can be used as one step towards the goal of weeding out, excluding out, we can say, uninteresting type of rules. So that would otherwise be presented to the end user. So after that, if we'll weed out, we can exclude those type of uninteresting rules, then that can be presented to the end user. So the misleading strong association rule, we will check for that. What is the misleading strong association rule? That is strong enough, but that is misleading also. So suppose, for example, we are interested in analyzing transactions in all electronics. The table we are having for that in the earlier slides with respect to the purchase of computer games and video. So let's game refer to the transaction that is containing computer game and video, that refer to those containing game video of the 10,000 transactions, that is analyze the data so that 6,000 of the customer transactions that includes computer games, while 7,500 include video and 4,000 include both of the computer games and video. So that this is the example we will check in the next slide. So this is only checking those of the statistics from that is having as I have said, the transaction that is containing computer games and video, the video that is having the 10,000 transactions, and that is containing the computer games that is only having the 6,000 transactions. The data that is having the video that is having the 7,500 statics count, and that is have those are the that is having the computer game and video all together, that is having the 4,000 data. So suppose for that, if the data mining program for discovering that association rules is run on a data using a minimum support of, we can say, 30% and minimum confidence of 60%. So the rule we will make for that, the voids x comma computer games, that it depends on the who voids, the users who are going to buy x comma videos. So that will be this computer games depends on the who buys x comma videos. So if we will calculate the support for this rule that will come as support will be 40% and confidence will be 66%. So the above rule is a strong association rule and would therefore be reported, since its support value of that comes from the 4,000 divided by 10,000, that comes as 40%, and the confidence value that is coming from 4,000 that is divided by 6,000, that is coming as 66%. So the both conditions, both of the support and confidence, that is satisfying the minimum support and minimum confidence threshold. But however, this rule is misleading. Why it is misleading? Because the probability of purchasing the video is 75%. While we are checking the probability of purchasing videos, that is coming at 75%, which is even larger than the 66% confidence. 66% confidence. Okay. So in fact, the computer games and videos that are negatively associated, here we can say the computer games and video are negatively associated because the purchase of any of the these items actually decreasing the likelihood of purchasing the other. So that is the condition that is misleading the association rule, which we have made as the one rule was we have seen in the example. So either this was the strong rule, but that is not necessary. That will be interesting. That will be interesting to for user if he is going to use or not. So that was the misleading condition. we have seen in this example. So like these type of rules can be mislead to users. Next topic is correlation analysis using some of the methods. So the support and confidence that measures are insufficient at sometimes, that is filtering out the uninteresting association rules. So in the earlier method we have checked this uninteresting association rule. So to tackle this type of weaknesses, a correlation measure can be found for that. That is used to augment the support confidence framework for association rule mining. So this lead to correlation rules for to form, like we can say A depends on B, that is having support confidence and also correlation. So we will in this method we need to check for the support confidence and correlation to both these all three together all together. So that is a correlation rule that is measured not only by its support and confidence but also by the correlation between items A and B. Okay. So some of these follows correlation analysis using lift method and correlation analysis using chi-square method. So the same table we need for that as an example, that was having the transactional data, all electronics which were having the transaction ID and list of item IDs, that is having T100 transactions up to T900, and the list of item IDs also respectively. So the first method is correlation analysis using lift method. So it is simple correlation method measure that is given as follow. The occurrence of item set A is independent of the occurrence of item set B. If A union B divided by P of A and P of B. Otherwise, items set A and B are dependent and correlated as event. That will also will be dependent and correlated as events. So this definition can easily be extended to more than two item sets. So this is having the A and B item set. But we can check this rule for the many of the item sets, more than two item sets. So the lift between the occurrence of A and B can be measured by the formula lift of A comma B, that is item set, is equal to P of A union B divided by P of A into P of B. So that is the formula to calculate the lift of item A and B. So if the resulting value is less than 1, if we will get the resulting value is less than 1, so then the occurrence of A is negatively correlated with the occurrence of B, meaning that the occurrence of one likely leads to the absence of another. So that will be the meaning of that the occurrence of one is likely leads to the absence of either the item set B. If these are the some condition we will get from this formula after we are calculating the lift for the item sets. So if the resulting value is greater than 1, then A and B are positively correlated. If the value will be greater than 1, then the occurrence of A and B will be positively correlated. That is meaning the occurrence of 1 implies the occurrence of B. So the third condition is if the resulting value is equal to 2, that will be if the resulting value after we are calculating the lift for some of the item set. So if that will be equal to 1, then the A and B are independent and there is no correlation will be between both. So these are the conditions we need to check. Either we are calculating the lift for that. So for example, if A corresponds to the sale of computer games and B corresponds to the sale of video, then given to the current market condition, the sale of game is said to increase, lift, we can say lift, that also we can call as increase, that is lifting the that is lifting the sale of the items. So that we need to calculate, that is said to be increase or lift the likelihood of the sale of videos by the factor of the value returned by equation. So that was the table on which we have associated these are the rules from that. So we will check the another method, that is correlation analysis using chi-square. So to compute the chi-square value, we take the square difference between the observed and expected value for a slot A and B pair. In the contingency table, we will also need to get the contingency table that is divided by the expected value. So this amount will be summed for the all slots of contingency table. So we will calculate the chi-square value. So to compute the correlation using the chi-square analysis for the nominal data, so this only will be used for the nominal type of data. So which of the data which is having some label, so that is called as a nominal data. So we need to observe, we need the observed value and expected value for each of the slot of contingency table. So that was the yes, that the table was the 2x2 contingency table that were having the game and video purchase. So this is the contingency table having game bar and summation row, and that is having the video bar and summation column. So that was the 2x2 contingency table. So we will calculate the chi-square for that. We are having the formula chi-square is equal to summation of observed value minus expected value whole of a square divided by expected value. That is nothing but expected value, that is observed value, expected value. So we will do the summation of that if we are having many data sets. So we'll do the summation of that, but we need to minus the observed value in the expected value from the expected value, and we will do the square of that, and after that we will divide by the expected value. So we from this from this contingency table we got these are the values, that is having the 4,000 minus 4,500 divided by 4,500. This is also having a square, plus we will check this for another item set that is having 3,500 and the expected value is 3,000 only. That when we will square of that and divide by that, so that is for every so on. So here we will get the chi-square value as 555 plus 555.6. So this is the chi-square value. So because the chi-square value is greater than this is the value is greater than 1, so the observed value of the slot game and video, and that is 4,000, which is less than the expected value of 4,500. Buying game and game and videos are negatively correlated. So here we find that is satisfying this negatively correlated condition. So this is consistent with the conclusion derived from the analysis of lift, we can say increase measure. So this was all the methods for the mining apart from the association rule. So we have till now we have completed our module 1 and 2. So we will meet in the third of the module of the program, that is called as data mining. So thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.